In this topic, we will discuss and compare the two methods, the Gauss elimination methods and LU decomposition methods, by comparing the efficient and the times to calculate. So, and at the end, you will answer this question. Firstly, to find the inverse matrix A, if I take Gauss elimination methods, you can see this table comparing computational times, finding inverse of the matrix using LU decomposition and Gauss elimination. So the times of the inverse Gauss methods is much more than LU decomposition. For example, for if the matrix n equals 10, so the times of the numerical method Gaussian elimination method is 3 times slower than LU. And in case n equals 10,000, it means the matrix 10,000 by 10,000. In that case, the method LU is very efficient and very quickly. So, how we can apply LU decomposition? So this technique is combines two methods. Firstly, is how we can apply the technique of triangular matrix, and then apply the Gauss elimination method. So it means LU decomposition is a little bit more complicated
I'll have to give
than
it to my
LU
cheeks again if this goes on much longer.
Gauss elimination methods. An LU decomposition method can apply to solve the linear equation. So we already learned three methods. Firstly is Gauss, second is Gauss shadow, and third one is Jacobi. And today we continue with LU. And second application for LU is inverting a matrix. And the last one is computing the determinants. Okay, let's see now how we can apply LU decomposition. In numerical analysis and linear algebra, LU decomposition, where LU stands for lower and upper.
I don't like
L is
weak
lower,
men.
U
Be
is
brave,
upper.
be bold,
So that's why we
get on
call
my
it
level.
LU decomposition. And also we can call LU factorization. And that is a factor matrix as a product of a lower triangular matrix and an upper triangular matrix. So do you remember what form of the lower and upper triangular matrix? So, okay, that is before this course we already have some slide to say that. And the technique is that firstly I have matrix A, system AX equal B is familiar with you. And now the matrix A can be factorized by two matrix L and matrix U. So that's why we can write A equal L and U. Our problem is how to find L and how to find value of the U. So it means lower and upper. L is a lower triangular matrix and U is an upper triangular matrix. Okay. And in the next slide, we will learn how to find the matrix L and how to find the matrix U. And LU decomposition was originally derived as a decomposition of the quadratic and bilinear forms. In very long times, we derived the algorithm we call Gaussian elimination. And later, Turing introduced LU decomposition of the matrix in 1948, that is used to solve the system of linear equation. And A is 1 mm with non-singular square matrix. Then the addict to matrix L and you subtract
What's with that
simplify
face? You mean
as
you
you
actually
equal
like
H.
these rags?
So here is the form of the matrix L and U. You can see L is the lower triangular matrix. It means from below the diagonals, we can see L11, L21, LM1. It's different zero. And above the diagonal matrix, we can see all elements above are zero. And inversely for the matrix Q, all elements below are zero. And all the elements above is not zero. And then for the system of linear algebraic equation A x equal B, this system can be rearranged to give, now you replace LU in this system. We have LU H minus D equal H minus D. So on the right hand, we will have always the system AX minus B equals 0. And on the left, we have L multiplied with the system of L UH minus B UH minus B. So if you multiply LU, we come back to the matrix A. LD in this case equal B. So suppose that now we can consider a system of 3-3. For the system 3-3, the upper trigonometry U multiply X equal D. And equation can be also expressed in the matrix notation and rearrange to give UH minus D equal 0. Okay, so do you understand this slide? Because in the first system, AX equal B, we replace A equal LU. So replace E equal LU in this system, we get L multiply UH minus D equal AH minus B. Because AH minus B equals 0, so UH minus D equals 0. Okay? So now you can solve for this system UH minus D equals 0. You know that is a triangular upper triangular matrix and vector T. If we know vector D, we can find vector H. So vector H is the solution of the system. So for the UH minus D equals 0. And now we come back to matrix L. For the matrix L, how we can determine all coefficients of the matrix L? L is that is once the diagonal. It means the element of the diagonal is 1. So in this matrix L, we have 3 by 3 means 9 elements. So 9 elements. Now we know all elements above is 0 and elements on diagonal is 1. So only 3 elements we don't know. It's F21, F31, and F32. And now we have to determine the values F21, F31, and F32. So in this slide, you can have the formula to calculate the 3 values.
You want me?
Firstly, F21 equal A21 over A11. F31 equal A31 over A11.